let's say I have GU of S equals so let's say I have this transfer function and U went up by 5. And let's say at time 0. Let's say at time 45. So let's put it this way. Let's quickly draw a qualitative response using the information that we have learned so far. There will be more things we'll be able to put in a minute. Now I'll continue, but before the break, I want to do one quick example, then I'll continue after the break with the rest. So U went up by 5 at time 45. Okay. So what can we tell? Let's follow them by the number. Actually, let's write first poles and see. I have 2 poles, -2 and -3. I have 1, 0 at +1. Right? If I were to put the picture, I have a 0 at +1, and I have poles at -2, -3. That's the picture.
Yeah, what's going on with that negative there?
Oh! Oops. Glad you guys are awake. Yep. That's the picture. Obviously, I didn't draw the right picture.
Wait, what did you call this picture? Like, what's the title? Is it the quantitative picture? Is that
No, it's the location of poles and zeros.
So it's not anything.
Just the location of poles and zeros. Years ago, I had a funny cartoon that had these X's and O's used for a control cartoon. Believe it or not, there are such geeky things as control cartoons. So I was making a tic-tac-toe game out of it, but unfortunately, my only copy, the janitor cleaned that outside my office, threw it away. Couldn't get it back. Joke, only students in my class would have understood. Anyway, so let's go through. First of all, stability. Are we stable? Yes. So 1, check. 2, new steady state. Where is the new steady state? Y prime infinity is going to be what?
-1 divided by 6.
Yes. So you put 0 for that, and you multiply, no, not quite. You multiply that by 5.
-5 divided by 6.
So, no. Okay. So you have -1/6, that's this, at 0, times 5, so -5/6. So y prime starts at 0 and will end up at -5/6. The step change happens at what time? At time 45. How much is my delay?
5.
So for the delay, I'm not going to move at all. So until time 15, I will stay here. Christian question? Different question.
They don't go up and then they go down?
So that's the oscillations. Do I have oscillations? No, I don't have a single, I don't have a complex conjugate pair, so no oscillations. Andrea, question? The new state, explain this picture? Yeah, okay. So y prime start at 0, right? Starts with no mistake, y prime starts at 0. So where will it end up? It will end up at g of 0 here, times u prime infinity. G of 0, you put wherever you have s, you put 0. So this is minus 1, 2, 3, e to the 0. So that gives me minus 1 over 6 to the g goes here. And what did y prime infinity do? U increased by 5, which means the deviation increased from 0 to 5. Okay? The actual u went from u0 to u0 plus 5, since it increased by 5. Right? U increased by 5. So it went from whatever is the beginning value to that plus 5. The deviation, which is u minus u0, went from 0 to 5. So u prime infinity, the new steady state value of u, is 5. So gu of 0 times u prime infinity is minus 1 over 6 times 5. So minus 5 over 6. Clear? So the new steady state is going to be minus 5 over 6. Yes, Rick?
Yeah, from where do you get the 6?
Because minus 1, putting s equals 0, I get minus 1, 2, 3, 2 times 3 is 6. 0 minus 1, 0 plus 2, 0 plus 3, e to the 0. Wherever you see s, you put 0. Okay? Caitlin, okay? Daniel? So we know where it will end up. No oscillations. And the new one is, do we have inverse response?
Yes.
Yeah.
What does that mean?
It goes up and then down.
First it goes up. Since I'm going down, inverse response means I initially move in the opposite direction. If I was going up, first I would be going down. If I'm going down, first I go up. So as we'll find in the next heuristic, it will look like. So that's what it would look.
How do you know it doesn't go up and then down and then a little bit up a bit? How do you know if it just goes up and then straight down to it, like a ramp?
Because it has, I can tell you that, but first of all, you don't have oscillations, so there's no reason for that to go down like that. And for that to have happened, you would have to have a second zero somewhere here.
Does the magnitude of the positive zero affect the magnitude of the inverse
Yes,
response?
yes, it does.
So the farther out?
Yes, the further out, the more pronounced it is. Actually, let me take it. Well, basically, the further out. Well, okay, I'll discuss something. All right, guys, it's time for your break. We'll continue with the next part, number 5. Immediately after our 15-minute break, we'll stop back exactly at 12:30.